Hi friends, in this video we see linear algebra concepts and questions asked in GATE exam, right? Okay, so the first thing we have to learn about linear algebra is system of equations. Right, this is a very important topic. They ask one question regularly in all TRB and the GATE exam. So the system of equation can have a unique solution, right? Or infinite solution, infinitely many solution, or no solution, right? Okay, let us see how to solve this type of problems. Okay, so let us take two equation. For example, let me take what you call two equation, right? So x plus y is equal to 3 and 2x plus 2y is equal to 7, right? This is one example I am taking. So here you see, let us assume that they ask with option whether these equations have a unique solution or no solution or infinitely many solution. Right, from here you see, if you multiply equation 1 by 2, so what will happen? 2x plus 2y is equal to 6, right? So 2 times of 1. But our equation 2 states that 2x plus 2y is equal to 7, right? So if x and y have a same value, same equation cannot be represented with the two different values, right? 2x plus 2y should be equal to 6 means it cannot be equal to 7. So both the equations should be representing the same thing, right? So it is different, so it has no solution. Fine. So this is simply, we can find any equation with no solution in the simplest manner, right? For example, let us take one more example. This question they are asked in GATE 2001, right? So what is the thing? X plus y is equal to 2, 2x plus 2y is equal to 5. They ask whether this has a single equation or unique one solution, no solution, infinite solution, or full solution. So easily we can say if I multiply equation 1 by 2 times, 2x plus 2y is equal to 4. So 2x plus 2y is equal to 4 means 2x plus 2y cannot be equal to 5. So surely this contains no solution. Right? Okay. Similarly, one more question they have asked in GATE 8 for EC paper. What is that? 4x plus 2y is equal to 7. 2x plus y is equal to 6. Right? So here you see, if you multiply equation number 2 by 2 times, it will become 4x plus 2y is equal to 12. If 4x plus 2y is equal to 7, it cannot be 4x plus 2y is equal to 12. So both the condition cannot be satisfied at the same time. So this contains no solution. Right? So in this way we can identify whether the given equation has one solution or no solution. Right? Similarly, suppose right, in general, if you have a two set of equation, how to identify whether the given equation has no solution or one solution or many solution, right? If our equation has the form, that is uh, we have an equation with x and y. If your equation has the form of x is equal to 3 or y is equal to 5, then we can say this is unique solution. Let me give example. Suppose if our equation has a form of 2 is equal to 5 like that, so it has no solution, right? Suppose if equation is a form of 0 is equal to 0 or 2 is equal to 2, then we can say many solution, right? Let me give you one example, right? Let us take this example. X plus y is equal to 3. And 2x plus 3y is equal to 8, right? So I want to find x or y first. So I multiply equation 1 by 2 times. So 2x plus 2y is equal to 6. So subtract, right, it will give, this will give y is equal to 2. So we got individual value. So it has unique solution. Y is equal to 2 means x is equal to 1. So only one solution. So this equation has unique solution, right? Okay, suppose I take an equation like this: x plus y is equal to 4 and 2x plus 6y is equal to 8, right? So what I do, I multiply equation 1 by 2 times. So 2x plus, let me take x plus 3y, x plus 3y is equal to 4. So 2x plus 6y is equal to 8. So what happens if I subtract 0 is equal to 0? I told it is something is equal to something, second and third condition, right? 0 is equal to 0 or 2 is equal to 2, like that. So this means this has infinitely many solutions, right? Because they may substitute any value for here and we can get the answer. Infinitely many solution. Okay, next. Let me give one more example. Suppose no solution we know already, right? So these are all the examples. Suppose if you have a three set of equation, right, like this. Okay, what is that? X plus y plus z is equal to 3, right? And x minus z is equal to 0 and x minus y plus is equal to 1, right? And we have to identify what type of, whether this has unique solution or many solution, right? In order to identify that, you just take determinant value. How you take determinant of coefficient? So first one has x coefficient 1, y coefficient 1, z coefficient 1. Second one, x coefficient 1, y coefficient 0, z coefficient minus 1. Third one, x coefficient 1, y coefficient minus 1, z coefficient 1. Right? If you simplify, what you get is minus 2. So let us assume this is a determinant A. Right? Since determinant is not equal to 0, this implies the given set of equation has unique solution. If determinant is 0, it has infinitely many solutions, right? Let us see one more problem. For example, what do you call? Let us take x1 plus x2 plus x3 is equal to 5, right? And x1 plus 3x2 plus x3, 3x3 is equal to 9, and x1 plus 2x2 plus 2x1 is equal to 3. Alright, I have to find whether this system of equation has unique solution or many solution. Let us see. Here 1, 1, 1, coefficient of x1, x2, x3. Here 1, 3, 3. Here 1, 2, 2. Okay, so I have to find the determinant value. You see, this column and this column are equal. If two columns are equal, surely the determinant value is 0. So the answer is 0. So determinant A, let us assume this is A. Determinant A is equal to 0. If determinant value is 0, then it has infinite solution. Fine? So in this way, we can solve problems like this. Okay? Right. Next we study about matrix. Okay. So next we study about inverse matrix shortcut, right? So I'm not going to tell the rules. I'm going to give only the shortcut, right? Okay. Let us see. Suppose they ask a question like this: which of the following matrix has inverse? which of the following matrix has inverse? Right? Let us assume they gave option like this: A is 2, 2, 2, 2, 2. B is 1, 2, 3, 4. Right? And C is 2, 6, 1, 3. D is 2, 4, 4, 8. Right? So I have to find it. So you don't need to find inverse for that. What is the only shortcut? We know A inverse is equal to 1 by mod A and adjoint A. Right? Moreover, inverse matrix doesn't exist for singular matrix. That is the important thing we must know. Inverse matrix doesn't exist for singular matrix. Singular matrix is one whose determinant value is 0. So I find what are all the matrices among these four has determinant value 0. For that we don't have inverse matrix. You see this has determinant value 0. 4 minus 4 0. So it has no inverse matrix. Next you see 2 into 3 6, 1 minus 6 6 0. So it has no inverse matrix. Here you see 2 into 8 16, 4 minus 4 16, 0. So it has no inverse matrix. This is 1 4 minus 6, that is equal to minus 2. So this one has inverse matrix. Okay. Let us see one more problem as an example. If A is equal to 2, 3, 4, 5, 6, 7. Right? What is A inverse? Right? This is the question. Let us assume. So we give right answer as 1, 4, 5, 2, 3, 6, and sorry, A. Option B as 1, 1, 2, 4, 3, 4. Fine. Okay. And C as what you've got 2, 1, 2, 1, 4, 2. D can't be determined. Fine. So what is the thing we have to do? If we want to find the inverse matrix, we have to find 1 by A, that is smallest value we have to find, adjoint value we have to find. But you see, inverse matrix cannot be found for non-square matrix. That is, inverse matrix can be obtained only for square matrix. That is the concept we must know. Inverse matrix can be obtained for square matrix only. So we cannot find inverse matrix for non-square matrix. So you see this is not a square matrix. Square matrix means it should be n cross n, right? Row and column should be same. Here row is 2, column is 3, so it is not n by n matrix, it is m by n matrix. So surely for this matrix we cannot find inverse. So the option is option C. Okay. Next, find inverse matrix. Find inverse matrix of what you call 1 0 0 0 2 5 and 0 1 3. Right? Okay. So for that we have to find inverse matrix. So inverse matrix means, as we know, A inverse is equal to 1 by mod A adjoint A. Fine. Okay, first I find determinant value. If I find determinant value 1 into 6 minus 5, that is 1. So if determinant value is plus or minus 1, then the matrix is known as orthogonal matrix. That we know already. Right? So for orthogonal matrix, what is A inverse? A inverse is equal to A transpose for orthogonal matrix. Right? We don't need to find adjoint. What is the thing we can do? We have to, A inverse means we have to transpose this. So A inverse is equal to A transpose. So transpose this 1 0 0 0 2 1. 1 0 0 0 2 1 and 0 5 3. Fine. So this is what inverse matrix for this equation, this matrix. Okay. So in this way we can find inverse matrix in the shortest form. For other things we can use formula. So if the questions are like this, we can find inverse matrix like this. Okay. Next we see some more shortcut techniques in matrix determinant, right? Okay. First one is if determinant determinant x is equal to 2 where x is a b c d e f g h I, right? What is determinant 2x inverse? So what they give, determinant x is equal to 2 they give. What they ask is 2x inverse. 2x inverse value. So 2x inverse determinant I can write as 1 by 2x. Right? So that will become 1 by, if I take 2 outside in matrix, the determinant, it will become 2 power n x. That is very important. Where n is equal to size of the determinant, right? So size of determinant, here it is 3 by 3. So n is equal to 3. So it is 1 by 2 power 3. Determinant x is 2. So 1 by 2 power 3, that is equal to 16. So what is the logic we have to understand here is, right? If I have a matrix A, determinant A, right? So it is x means determinant Ka becomes k power n A, right? So if you take a constant outside, it will become n, n is the size of determinant. This is the thing we must remember, right? So this is one type of problem we can expect, and they ask in gate also. Fine. Next one. Okay, so here we see next problem. If A is 3 by 3 matrix, right? And mod determinant A is 3, then what is A into Hj A, right? So we know A into Hj A is given by A into In. N is the size of the determinant. So it is 3 by 3. So I is the identity matrix. So it is 3 by 3 matrix. So 3 by 3 identity matrix. So 0, 1, 0, 0, 0, 1. And it is identity matrix. N is 3. So because A is a 3 by 3 matrix. Okay, so what will happen? So A they have given, yes, they have given, yes, A determinant A they have given, it is 3. So 3 into 1, 0, 0, 0, 0, 0, 0, 1. So the answer is 3, 0, 0, 0, 3, 0, 0, 0, 3. This is another thing we have to remember. Okay, next what type of problem with the shortcut we can identify? So suppose if they ask, right, if A is non-singular, singular matrix means determinant is 0, and 2 by 2 matrix, right? What is adj A? So first A adj A here, adj A, adjoint F adjoint A, right? So what we have to find adjoint of A. So we know the formula adjoint of adjoint A is equal to determinant A power n minus 2 into A. Here A is the size of the matrix. Yes, sorry, n is the size of the matrix. So A into n is 2 by 2, so it is 2. So 2 minus 2 into A. So that is equal to A. So adjoint of adjoint A is A. So this is the formula we have to know, right? This we must remember. Okay, fine. Okay, next, what type of different problem we can expect? If what you call determinant A is equal to 2 and it is 4 by 4 matrix, right? Then what is adjoint of adjoint A, right? So now just now only we have seen A formula. So adjoint A is equal to mod A n minus 2 into A, right? N is 4. It is a number size of the matrix, so 4 minus 2 into A. Fine. So it is mod A squared into A. Determinant A they have given, so it is 2 squared into A, that is 4A. So the answer is 4A. In this type of question, we can expect this type of question. Suppose if they ask what is mod or matrix or determinant of adjoint A. If the question is like this, the formula is A mod e power n minus 1 whole square. So determinant A, n is again what you call 4 minus 1, 3 square. So it is A power 9. So determinant A they have given already 2. So it is 2 power 9, that is equal to 512. Fine. So in this way we can solve the problems like this, right? Okay, next, suppose if they give question like this, if x and y are of 3 by 3 matrix, okay, then and x is equal to 3y, right? So also determinant x is equal to ay, right? Then what is a? This is the question, simple question only, right? Okay. So a value they ask. This is a very easy problem. What they have given, x is equal to 3y they have given. We know determinant x is equal. If x is equal to 3y, determinant x is equal to determinant 3y. Fine. So I told already, if you take a constant outside, it will become 3 power n y, where n is the size of the matrix. So here it is 3. So 3 power 3 y. So what will happen? It will become 27 y, determinant y. What is that? X. So x is equal to ay means compare these two equations. So what is a from this? Comparing these two equations, what we get? A is equal to 27. Simple. So in this way we can find or solve the problems like this. Okay. Fine. Next we see eigenvalue related problems. So shortcut for eigenvalues. Shortcut for eigenvalues. Okay, what is that? What is the eigenvalue of, suppose the question is the eigenvalues of A is equal to 1, 2, 3, 0, 4, 5, 0, 0, 6. They ask us to find the eigenvalue of this matrix. So whenever the questions like this come, it is very easy to identify. You see it is a upper triangle matrix because lower part is 0. So it is a triangular matrix, right? So what is the shortcut we can use? Eigenvalues for triangular matrix. Eigenvalues for triangular matrix are its diagonal element. So it's a triangular matrix. So what are the diagonal elements? 1, 4, 6. So the eigenvalues for this matrix is 1, 4, 6. Simple, right? Similarly, for upper triangular matrix also the same answer will come. So suppose if they give matrix like this 1, 2, 0, 3, 4, okay, 4, right, right. So okay, 3, 4, right, 5, right. So you see, compare both the equation. Sorry, 1, 2, 3. That's fine, right? It is a upper triangular matrix. You see this one 1, 2, 9, 3, 4. So this is a triangular matrix. So for this also the eigenvalues are diagonal elements. So what are the eigenvalues? Eigenvalues are 5, 4, 9. Right? It is lower triangle. It is upper triangle. Right? So in this way we can find what you call eigenvalues. Okay, the shortcut method. And second one is, suppose let us have a matrix like this. If A is equal to 2, minus 2, 3, fine. Minus 2, minus 1, 6, 1, 2, 0, right? And they gave if one of the eigenvalues, if one of the eigenvalues, if one of the eigenvalues is minus 5, what are other eigenvalues? What are other eigenvalues? Right? So, and they give the option like this, right? Okay, what is that option? 1, sorry, 2, 3, B, 3, 3, C, 4, 3, D, 5, 3. How to find? We know where the one of the main property of eigenvalues is what is that? Sum of eigenvalues is equal to sum of diagonal element. So sum of diagonal element. This is the important property of eigenvalues. So we know one eigenvalue is minus 5. You see sum of diagonal elements 1, 2, minus 1, plus 0, 1. So one eigenvalue is minus 5. I have to add remaining 2. So 2 plus 3, 5. Sum means 5 minus 5, 0. So it won't be answer. 3 plus 3, 6. 6 minus 5, 1. This may be answer. 4 plus 3, 7. 7 minus 5, 2. So it is not answer. 5 plus 3, 8. 8 minus 5, 3. So this is not answer. So I have to get sum of eigenvalues should be equal to sum of diagonal element. Sum of diagonal element is 1. If I sum all the 3 eigenvalues, I get 1. So option B is the right answer. In this way we can solve the problem. Okay. Then simple question, if the determinant A, if matrix has eigenvalue of 1, 2, 3, right? What are the eigenvalues of A transpose? If A has eigenvalue of 1, 2, 3, what are the eigenvalues of A transpose? We must know A and A transpose have same eigenvalues. That is the important property. Right, same eigenvalues. So A transpose has eigenvalues of again 1, 2, 3, 1. This is the shortcut we must remember, or property of eigenvalue I can say. Okay, next, if A, what can I do? Okay, fine. If A has eigenvalue of 1, 2, 3, then eigenvalues of A square is A square of, what is the shortcut we can use? See, if matrix has eigenvalues of A power n has eigenvalues, let us assume A has eigenvalues of lambda 1, lambda 2 up to lambda n, then A power n has eigenvalues of lambda power n, lambda 2 power n, right at lambda n power n. So I want eigenvalues for A square. So what is the eigenvalue of A square? 1 square, 2 square, 3 square. So the eigenvalues are 1, 4, 9. This is the answer. This is another property of eigenvalue we can use to it. Okay. Right, next. Another important problem like this we can expect if determinant A as 4 and A as eigenvalue of 248, right? Then eigenvalues of adjoint A, right? So this is the question they ask. So we must remember one property of eigenvalue. Eigenvalues of adjoint A is equal to, what is the thing? Determinant A by first eigenvalue, determinant A by second eigen, determinant A by third eigen, like that it will go. So here they have given A value, so it is 4, first eigenvalue is 2, again 4 second eigenvalue, 4 third determinant 4 by 8. So we have A as eigenvalue of 248 means adjoint A as eigenvalues of 2,1.5, like that we can say, right? So eigenvalues of, so what is the property? Eigenvalues of adj A is mod A by first eigenvalue, mod A by second eigenvalue, mod A by third eigenvalue. Okay, next. Okay, next, if A as eigenvalue of 3 to 1, then what is determinant A? So we must know one property, product of eigenvalue is equal to determinant, eigenvalue of A is equal to determinant A. So this is the property we must know. Product of eigenvalue of A is equal to determinant A. So what are the eigenvalues we have? 1, 2, 3. So eigen product is 1 into 2 into 3, 6. That is equal to determinant value. Sum is equal to diagonal, right? Sum of eigenvalues of A is equal to diagonal element of A, right? Sum of diagonal elements. Okay, so determinant of A is equal to product of eigenvalues of A, right? So this is another property. Okay, next, and another one important thing we must know about eigenvalue is if a matrix A has eigenvalues of 2, 4, 8, right? Then eigenvalues of A inverse. So we must know the important property of eigenvalue to solve this problem. What is that? A as eigenvalue of this one means A inverse. A inverse, if property is, if let us assume A as eigenvalues lambda 1, lambda 2, lambda n means A inverse as eigenvalues of 1 by lambda 1, 1 by lambda 2 up to 1 by lambda n. So this is the important property. So what is the thing? Here what they are given? Eigenvalues of 2, 4, 8 they are given. So A inverse has eigenvalue of 1 by 2, 1 by 4, 1 by 8. So this is the property. A as eigenvalue lambda 1, lambda 2, lambda n means A inverse has eigenvalue of 1 by lambda 1. Like that we have to find the answer. Okay. Next, suppose if A is given like this, A is 1, 2, 3, 4, 5, 6, 7, 8, 9, then what is the question they ask? Sum of eigenvalues. Sum of eigenvalues. So you don't need to find eigenvalues and sum it up. What is the property we have? Sum of eigenvalues of A is equal to sum of diagonal elements of A. So what is the sum of diagonal elements? This is the sum of diagonal elements. That is 1 plus 5 plus 9. So that is equal to 15. Right? So in this way we can solve this type of eigenvalue problems. Right? So I hope you understand all the logic. If you have any doubt, please ask me in comment section. I will clarify. Thank you.